I'm Anil Kumar. In this video, we'll take up 3 examples based on enlargement of objects. So in the first example, I will consider a triangle which will be enlarged by a factor of 3, which we call scale factor, and the center of enlargement will be considered inside the triangle, the point D shown in this particular figure. Then we'll take up another example where the center of enlargement will be outside the object. So we have a triangle ABC and we'll enlarge it again by a factor of 3. However, center of enlargement at D, where D is outside the object. Now once we have understood how to do enlargement of objects, we'll also figure out if the enlarged objects are already given to us, how to find center of enlargement, right? So with this, we'll get fairly good idea about this topic on enlargement. In another set of videos, I've considered how to translate objects, how to reflect them, how to rotate them, and then we'll take a few questions to practice. And I hope with these few videos, you will be good for transformation related to objects. Now let's begin with the very first example. Let's call this as an example 1 on enlargement. The question here is, determine the coordinates of triangle enlarged by a factor of 3 from the center of enlargement at D. So we've taken this point D right in the body of the structure, which is a triangle. So let's write down all the 3 coordinates first. So coordinate points for A is 1, 1. For B, it is 4, 2. And for C, it is 2, 3. Let's also write coordinate points for D. It is 2, 2. Now we'll see how the coordinate points of D affect the enlargement at the end of this video. Now first is by a factor of 3. Now in this case, if you see, if I move from D to A, we are diagonally moving 1 unit. Scale factor is 3. That means we have to do 3 times. Is that okay? So let's go 3 diagonals. So 1, 2 and 3. So we get to a point which we'll call as the image of point A after a scale factor of 3. Similarly, for C, which is vertically up by 1 unit, we can go 3 units up and get to the point C dash. That one is horizontally, but let me show it the other way. Well, let's go horizontally first and then I'll show you the other way. It is 2 units horizontally. So 2 times 3 is 6. So 2, 4 and 6. That gives me point B dash as an image for the enlarged object. Now the idea is just to connect them so that we can see how this triangle will look like. Clearly the shape is similar to what it was, but it has increased in size, right? That is what we call enlargement, right? So let me join these points and that's how you get your answer. Now in this case, it was pretty simple. We just went diagonally 3 times the original distance to get to our points. The alternate method could be when I do not give you the triangle on a coordinate plane. In that case, how are you doing? How are you going to do it? That's a big question. So I'll give you a strategy here to understand what to do when we are not looking at the graph, right? We're just looking at the points. Now the idea here is that the distance D to A, change in X and change in Y is what we look forward to. So as far as this is concerned, from D to A, we move 1 left and 1 down. So the change is -1 and -1, correct? And that has to be multiplied by 3. Now this changes from D, correct? Since D is your center of enlargement. Now we are saying it has to be 3 times this away from D. That means from 2 I have to take away 3, and from this 2 also I have to take away 3. When I do that, what do I get? I get A dash, which is 2 minus 3, which is minus 1, 2 minus 3, which is again minus 1. Do you see how I get minus 1 minus 1? Now let's do it once again, and this time we will do for point B. So you have to understand the concept. So B is change in x by 2 units. That means change in x by 2 units, but y remains same. So 2 units and scale factor of 3, that means multiply by 3. Minus 2 times 3 is, we have to go right, so positive 2. So positive 2 times 3 is positive 6. So B dash, the image of B after enlargement by a factor of 3 should be 6 plus 2, 8. But the y value remains same, which is 2. You get an idea, right? Now let's do once again. I hope it'll be absolutely clear now. So from D to C, there is no change in x. So the change in x is 0. However, the y value increases by 1. We have to multiply by 3. So 3 times 0 is 0. Add it to 2. You get just 2. 3 times 1 is 3. Add it to 2. You get 5. So 2, 5 is the coordinate point for the vertex C. So this point here is 2, 5. You get an idea. So that is how you could actually perform transformation on the given points and get the new points. Perfect. So as you can see that the points which we are looking forward to are, let me write down the final answers. A is minus 1, minus 1. B is 8, 2. And C is 2, 5. Perfect, the concept. Now let's move on to example 2. Okay, so here is example 2 for us. We have point D, which is center of enlargement outside the triangle, correct? So this is very important to understand. When it is outside the triangle, how to do it? So let us again begin by writing down our points, right? So we'll write down our points. Let me make these columns once again. So this time I'll make 2 columns. One, we will say column for change, okay? So the first, let's write down the coordinate points. Point A for us is minus 3, 2. These are xy points. B is minus 2, 1. And C is 1, 3, minus 1, 3. Okay. Point D, which we are talking about, is at minus 4D. So D is minus 4, 2. Perfect. Now, in this particular case, we are also multiplying by 3, which is the scale factor. Now, if you see, what is the change from D to A? Now, D to A change is along the x-axis, we are adding 1, right? So it is plus 1 along x-axis, and y, there is no change. Perfect. Now, this has to be done 3 times. When you do it 3 times, then you have to add to the original point, correct? That is the concept. So what do you get? So 3 times 1 is 3. And when you add 3 to minus 4, you get minus 1. As far as the y value is concerned, it is same, unchanged, it is 2. So A dash should be at minus 1, 2. So let me show that point here. So minus 1, 2 is the position for A dash. Do you get it? So what we are saying here is kind of like this. Initially, D to A is 1 unit, correct? Multiplied by 3, it is 3 units. 1, 2, and 3. Do you see that? 3 times. That is what we mean. And we can get this point with the coordinate points. Okay? Now let's do this calculation once again. It is very important since these types of questions can be asked without a graph here. We can work only with values. Point B. So if I have to move, how much do I move from D to B? As far as x value is concerned, 2 units right. So we do plus 2 as far as x is concerned, and y 1 down, minus 1. And we have to multiply this by 3. So 3 times 2 is 6. When you add 6 to minus 4, what do you get? You get 2, right? 6 minus 4. Minus 3 plus 2 is minus 1. So point B should be at 2 minus 1. So that should be point B dash, image of B. Now let's see like this. Earlier, B was 2 units to x. Now it will be 6. So 2, 4 and 2, 6. As far as going down is concerned, we went down by 1. So here we are. This is B, right? So we went down by 1. Now you have to go down by 2. Do you see that? You come here. So those were the 6 units, right? So from D horizontally. So you reach at this position B dash. Does it make sense to you? Once more. For C, if you are checking from D, as far as x is concerned, you move 1, 2, 3 units to the right. As far as y is concerned, you move 1 unit up. This has to be multiplied by 3 since we have a scale factor of 3. 3 times 3 is 9. When you add 9 to minus 4, you get 5. And when you add 3 to 2, you again get 5. Is it okay? So the point C should be at 5, 5. So that is the image of C. So once you join these points, you get your final figure. So we have A dash here and C dash there. So let's join them. So look at these points and just join. And then we have B dash and C dash. We just join them also. And similarly, let me join A dash and B dash. You get enlarged triangle. Now this triangle has been enlarged with center at D, which is outside the figure. Do you see that? So that is how it could be done. So I've shown you how it could be done easily with the help of coordinate points this time. Now let me teach you one more thing which is of prime interest to figure out where the center is if we are given 2 images, right? So we have this image which is times 3. Now if I join these 2 points, then see what happens. Let me join it from D itself and show you what am I trying to say. So let me join these points from D. So see like this. So you have to do it neatly so that you get better graphs and lines. Okay, and if I join this point also, do you see what? All these lines focus at D. So if I connect these 2 points and extend, I get my center of enlargement. If I connect this and extend this and extend, all the 3 lines meet at the center of enlargement. So this is the concept which you can use for the last example and find center of enlargement. So what do we have here? The question is, find coordinates of the center of enlargement. So what you should do now? Well, these are the 2 figures. We can also figure out how much are they enlarged. Can you tell me? By what factor? Well, distance from A to D is 1 unit and here it is 2 units. So the scale factor is 2. Perfect, because you could see it clearly, right? Now, to get the point, what we can do is, well, we can connect these points, right? So we could connect these points. It is like going 2 up and 1, 2, 3, 4. So we say 2 up, 1, 2, 3, 4. 2 up, 1, 2, 3 is far away. Anyway, we have some line here. So let me just connect these points. You learned the concept in the previous example, correct? Now here A to A dash is 1 up and 1, 2, 3, 4. So we'll go 1 up, 1, 2, 3, 4. So it seems that it is joining at this point. Is that okay? So you just connect these guys. Okay, these points A dash with A. Similarly, we could do with C also, right? So it is 1, 2, 3 up and 1, 2, 3. So we do 1, 2, 3 up and 1, 2, 3. It's the same point again. So let's connect. So if you connect these points, everything converges at a point which we are calling D. And that is the center of enlargement. And this is how you get it graphically, right? This is 6, 4. So we get this answer as 6, 4. So the coordinates for center of enlargement are 6, 4. That's our answer, right? So that is how you get it very easily from a graph. So they converge at a point. So if you connect B dash to B, it will also converge to the same point. So that's the focus point, correct? So I hope with this video you understand all the concepts about enlarging objects when the center of enlargement is within the figure or outside the figure. And if I give you two figures which are scaled by some factor, you can always find the scaling factor and also center of enlargement. I hope you enjoyed this journey of learning about enlargement of objects. We have a series on this topic where we're talking about reflection on the axis, translations, left or right, and rotations. So you can look into more videos and learn more about enlargement, rotation, reflections, and all kind of transformations related to objects. Feel free to post your questions, and if you like and subscribe, that'll be good for me. Thank you and all the best.